Let's continue with section 5.2, normal distributions, finding probabilities. So in 5.1, we started the idea of the bell-shaped curve and it corresponding to probabilities, where all the probabilities equal 1. And we also introduced and we worked with the standard normal distribution. And standard normal corresponds to the measurement among z-scores. And with that, we worked with a mean of 0 and a standard deviation of 1. Now for this section, we're going to take what we learned. The only difference is our mean. It will be whatever we're told it is or whatever we have to calculate it being. And same thing for your standard deviation. These values will be given or we'll have to calculate them ourselves. So just to remind you, we do have some calculator and Excel functions that make it easier for us. We have normal CDF, and we have to enter 4 pieces of information, and norm dist, and we have to enter 5 pieces of information. Let's do an example. A national study found that college students with jobs worked an average of 22 hours per week. The standard deviation is 9 hours. A college student with a job selected at random. Find the probability that the student works for less than 4 hours per week. Assume that the length of time college students work are normally distributed and are represented by the variable x. So when it says normally distributed, that's important because that lets us know that we're allowed to work with the bell-shaped curve. So that's an important statement to look out for. Now here, we read it once, but if we were in class or if you were doing it by yourself, I would definitely take the time to read the problem, let's say 3 times. First time is just to get a sense of what the story is saying. Second time, you kind of get an idea of what you're being asked, may start highlighting values. And the third time, just to make sure you understood it correctly. So at the very, very least 3 times, but read it as many times as you need. So here we're told that we have a mean of 22. We have a standard deviation of 9. And we want to find those values that are less than 4. Okay, so let's label those pieces. On our bell-shaped curve, that middle peak is our mean. And we have to keep in mind that we have a standard deviation of 9 because we're going to be using that. Now our question wants us to find the values that are less than 4. All right, so if 22 is our middle or average, we want to find those that are 4 or less. Now it's not totally, how would I say? It isn't correct. All I want to know if it's the left or the right of the mean. So it's not totally up to scale. All right, let's find our answer. Now you can be using either Excel or your calculator. Handy right now I have the calculator. So I would be entering this as normal CDF. And we have a negative infinity. So a negative big number and a stopping point of x, an upper value, an upper limit of 4. Then your mean of 22 and your standard deviation of 9. So you press second bars, the second option, and let me enter those values. And I just turned off my computer too. So we have 0.0227500062. You only want maybe about 2 or 3 decimal values. So I have 0.02, and because we have a 7, we round up. So we would say 3. But I know we're working with MyMathLab. They tell you exactly how many decimal places they'd like. So here we have it. It's just like our last section, but we get a story and we have to find what the mean and the standard deviation is within our story. Let's do another example. A survey indicated that for each trip to a supermarket, a shopper spends an average of 43 minutes with a standard deviation of 12 minutes in the store. The lengths of time spent in the store are normally distributed and are presented by a variable x. A shopper enters the store. 1. Find the probability that the shopper will be in the store between 22 and 52 minutes. 2. More than 37 minutes. And 3. Consider probabilities above when 200 shoppers are in the store. All right, so let's take a look at this question. So, 1. We need a mean. We're told we have an average of 43 and a standard deviation of 12. And now each part is asking for a certain value. For 1, we want the values between 22 and 52. So we have a average of 43, and we want to keep in mind that our standard deviation is 12. All right, we want between 52 and 22. Now again, it's not up to scale. We just want to have an idea what we're looking at. All right, so I have a calculator handy. This is our lower value, and that's our upper value. So we have normal CDF 22, 52 with a mean of 43 and a standard deviation of 12. And our answer is 0.7333133607. So our answer would be 7.33. That's 1. 2. Same bell-shaped curve, some information, but now we want a different probability. So we have a mean, we were told 43 and a standard deviation of 12, but now we want more than 37 minutes. So 37 is a bit less than 43. We want more than 37. So we want the complement. Know that your calculator in Excel by default do left, but we want the other side. So you would do 1 minus. So in your calculator or Excel, you will enter it as 1 minus and then your command. So normal CDF, our lower is 37, and our upper is positive infinity. So enter a really big positive number. Our mean is 43, and our standard deviation is 12. And our answer is 0.6914624678. So it's about 0.691. All right. Now 3, consider probabilities when we have 200 shoppers in the store. All right, so when we have 200 shoppers or more, all we have to do is go ahead and multiply our probability by 200. So 3. So if we read 1 for 3, what's the probability that 200 shoppers are between 22 and 52 minutes? So we have 200 times our probability from part 1, 0.733, and we get 146.6. We can't cut people into fractions, so let's round to the nearest whole person. So we can expect to have, if we have 200 shoppers, 147 of those will be between 22 and 52 minutes. All right, let's take a look at 3 for part 2. So we're going to take our probability, multiply it by 200, and that gives us 138.2. Let's round to the nearest whole person. So we can expect out of 200 shoppers, 138 of them will be in the store between or more than 37 minutes. All right, so this is section 5.2. Again, we're working with the bell-shaped curve, and we're learning how to apply the mean, the knowledge of the mean and standard deviation to know a value up to a certain point or below a certain point of the curve, and providing some probability. Again, my focus here is that you can interpret your question and know how to give an appropriate answer for it. The math isn't the point of concern. Please use your technology, use Excel or a calculator, whichever is easiest for you to have access to. All right, that's it for this section. Thank you.